This video is going to go through Newton's first law. I do want to apologize. I think the background noise is going to be a bit higher in this sequence of videos. I'm in a different room and there's a very loud air handler. I'll try to fix that for future videos. So in this sequence of videos, we're going to talk about what Newton's first law is, and then we're going to talk about where we actually use it, which is the idea of mechanical equilibrium. We will start relating equilibrium to forces, and we're going to return to this later in the next chapter. And then the last little topic we talk about here is the idea of accelerating reference frames, which isn't going to be something we use a lot, but is important to understand why we don't want to use it. The main topic that this relates to is the idea of problem solving, that understanding Newton's first law and equilibrium is going to be very important for many of the force problems that we deal with. So this is the conceptual foundation for a big category of problem solving, and this is largely coming from section 5.6 in Knight. So here is just the flat-out quote. I'm not necessarily going to read this to you, but this is what we say Newton's first law is. Now on the next slide, I'm going to turn it into mathematical or a representation in notation and variables that I think actually makes a lot more sense. But let me try to highlight here the important things that hopefully will come up and that you can think about. First, we're talking about an object. Why do we care about objects? Well, in physics, we're always modeling the behavior or the motion of something. So again, when we're working with forces, we need to understand what object we're dealing with. So this is referring to a specific object. And then of the things that are stated after it, there are actually two statements with an or in between. So at rest will remain at rest, or, so this is option 1. Option 2 is moving will continue to move. Now note that this actually keeps going in a straight line with constant velocity. Okay, so there's actually, two parts here. And this here is number 2. So we have an object, and the two conditions we're talking about is that it's at rest, or it's moving in a straight line at constant velocity. And if either of those are true, we know that the net force acting on the object is 0. Big ol' 0. So there are two conditions to worry about, and in either condition, the net force acting on the object is 0. And I'm just going to remind you that when we talk about net force, we might say this is the sum of all forces, or we might just write it as F sub net, where these are the same thing. So just total forces. And in this case, we're saying that it's equal to 0. So at rest, remain at rest, or constant motion in a straight line with constant velocity. So when we talk about Newton's first law, some students might actually memorize this very long sentence here. You don't need to do that. But what I do want to point out, and I will return to this over and over again in this sequence of videos, is that there's two conditions here where it could be true. Either an object at rest or an object moving in a straight line with constant velocity. So let's look now at what this actually means just in terms of some symbolic notation. Now, this is much simpler. There's much less here. And so again, we're saying if F net is equal to 0, the sum of all forces is equal to 0, then, and I'm not using fancy logic notation, I'm just using a right arrow, the change in velocity is equal to 0. And remember that this delta means change in, and here I've made it clearly the velocity vector. So what does this mean? This means that speed is constant, right? But it also must mean that direction is also constant. So that's really important to remember. So again, a changing velocity vector could either be changing in speed, direction, or both. So if we say that delta v is equal to 0, the speed must be constant and the direction must be constant. Another way that we would write this is that the acceleration vector is equal to 0. Part of why I'm writing it as delta v rather than acceleration is that we usually write it as an object at rest stays at rest, or an object in motion continues in motion in a straight line at a constant speed. So both of those are explicitly referring to changes in velocity, though that is just how we define acceleration. So now, the reason that I've written it here is that we can flip it around. So if you know, the first line says, if you know this, right? If you know that your net force is equal to 0, then your velocity must not be changing. But we can also flip it around. If your velocity is not changing, then you can infer that your net force is equal to 0. So if one of these is true, the other one is true. This is the idea of saying if and only if. So whichever way makes more sense, either in words or with this notation, that's the idea of Newton's first law. But again, the thing that I want to stress is it isn't just an object sitting still has no net force, but it also is an object traveling at constant speed in a constant direction.